Good morning. I am Kavita, working as assistant professor in Sri Muthukumaran Institute of Technology. Today I am going to present a topic in Introduction to Operating System. Topic is memory management. What is memory management? Memory management, which is nothing but it is an operating system function that manages and coordinate the computer's main memory, what is called as RAM. Memory management is the functionality of an operating system which handles or manages primary memory or moves process back and forth between main memory and disk during execution. It keeps track of which part of memory are in use, which part are free, allocation and deallocation of memory, movement of data between memory and disk. The main function of memory management is memory allocation, memory protection, address translation, memory sharing, and virtual memory management. Why we are using this memory management? Memory management is a limited resource. Multiple processes need memory simultaneously. So the reason behind that, efficient utilization of memory, protection between process, sharing of memory resources, support multi-programming, and improve system performance. For example, without memory management, there are two processes are using. Process A may overwrite and process B is memory area. This causes error and system crashes. And the main objective of this memory management is reallocation, protection, sharing, logical organization, and physical organization. To explain how memory management is organized in a computer and to explain memory management method like paging and segmentation and explain the Intel Pentium system that supports segmentation and paging. And the background was early system executed only one process at a time. Modern system are execute multiple process simultaneously. Therefore, memory management become essential. Main memory and register are the only storage CPU can access directly. The register access in the CPU clock or less. A main memory can take many cycles. Cache sits between main memory and CPU registers. It protects of memory required to ensure correct operations. The hardware protection with the base and limiter register, which is nothing with the address protection that ensure a process access only is allocated memory. It has a base address and limit register. The base address register which is contains starting address of the process, and limit register which contains size of the process memory area. For example, the base register is 3000 and limit register is 1000, means the valid address is 3000 to 3999. The hardware check first CPU address and then address limit. If the limit is okay, means add base register and then go to the physical address. If the address exceeds limit, a trap error may occur. The advantages of this hardware address protection is memory protection, process isolation, secure execution, and address binding. Address binding, which is nothing but it is a process of mapping program address to memory address. The type of address binding is compile time binding, load time binding. It is convenience to have first user process physical address always at 0. How can it not be? The further addresses represent in different way at different stages of program life. The load time binding, the address determined when program is loaded, and execution time binding, the address determined during execution. In the binding of instruction, which is here there are three different stages. One is compile time, load time, and execution time. In compile time, the memory location priorly known, it absolute code can be generated, and in load time is generate a reallocatable code if memory allocation is not known at compile time. The execution time is binding delayed until run time if the process can be moved during its execution from one memory segment to the another. And in logical versus physical address space, logical address generated by CPU, it is also called as virtual address. And in physical address, actual address in RAM. Comparisons of logical address and physical address are: it generated by CPU, it located in a RAM. Logical address is visible to user and physical address is visible to hardware. Logical address is virtual and physical address is real. And memory management unit, it is a hardware device that translates logical address into physical address. When the base register and logical register combine together and form a memory management unit, and the function is address translation, memory protection, and virtual memory support. And then loading dynamic allocation using reallocation registers. Your routine is loaded into memory only when it is called. And then the main advantages is save memory, faster loading, better memory utilization. For example, error handling routines are loaded only when required. Dynamic loading. In dynamic loading, a routine is not loaded until it is called. Better memory space utilization. Unused routine is never loaded. All routines kept on disk is reallocated load format. And then dynamic linking. It has a libraries and it occurs during execution rather than completions. It has a static linking and dynamic linking. In static linking, it has a program and then library, and then it has been executed. In dynamic linking, the program have a shared library loaded during the time of execution. The main advantages of this is smaller executable files and it is easier update. Also shared libraries and the main example for this is shared memory libraries. And then swapping technique, which is nothing but it is a process of temporarily moved from RAM to disk and later brought back. The main purpose of swapping is free memory space and increase multiple programming. The steps involved in swapping are: process moved into backing store, another process is loaded, original process reloaded later. And then this is the example for a swapping. And then the main advantages are better memory utilization and more process can execute. And then contiguous allocation, each process copies one continuous block of memory. Main memory usually into two partition. Resident operating system usually held in low memory with interrupt vector, and the user process then held in high memory. Each process is contained a single contiguous section of memory. It is simple implementation, fast access, and the external fragmentation and difficult memory allocations are some disadvantages in contiguous memory allocations. And a degree of multiprogramming limited by number of partition. And then the whole block of available memory holes of various size are scattered throughout memory. The operating system mainly informed about allocated partition and free partition. In dynamic storage allocation problem, how would satisfy a request of size n from a list of free holders? First fit, best fit, and worst fit. First fit allocate a first hole in that is big enough, and in best fit allocate the smallest hole that is big enough, and in worst fit allocate the largest hole. Must also search the entire list. And coming to fragmentation, fragmentation is a wasted memory space. It has external fragmentation and internal fragmentation. Total memory space exists to satisfy a request, but it is not contiguous. And in internal fragmentation, it allocates memory may be slightly larger than requested memory. The size difference is memory internal to a partition, but no being used. It reduces external fragmentation by compaction, shuffle memory content to place all free memory together in one large block. The input-output problem is large job in main memory while it is involved in input-output. In input-output only into operating system buffers. Thank you.